In this video, I will explain the concept related to Ldpc codes. Ldpc code. Ldpc code is a linear error correction code that is like a linear block code that has a parity check matrix H, which is sparse, that is with less non-zero elements in each row and in each column. This is the H matrix. H matrix. Some rows and columns are there. These are the rows, row 1, row 2, and so on. These are the columns, C1, C2, and so on and so forth. Some columns are there. This is the H matrix, Ldpc, low density parity check code, is a linear error correction code that has a parity check matrix H, which is sparse. Sparse means with less non-zero elements. Less non-zero elements means ones in each row and column. Next. Low density parity check codes are codes specified by a parity check matrix containing mostly zeros and only a small number of ones. This parity check matrix consists of most specified by parity check matrix H contain mostly zeros like that. Mostly zeros and only a small number of ones like that. Ldpc code is represented by irregular and irregular Ldpc codes are there. Later I will explain. A regular n comma wc comma wr Ldpc code is a code of block length n. Code of block length. This is the block length. Block length. WC is the weight of the column. WR is the weight of the row. Weight of the WC is the weight of the column, means number of. WR is the weight of the row, that is the number of ones in each row. Ldpc code is a code of block length n. N is called as a block length with a m cross n parity check matrix. This one is the parity check matrix. The order of parity check matrix is m cross, where each column contains a small fixed number, that is WC greater than or equal to 3. WC is equal to 3 or WC is greater than or equal to 3. WC is called as the weight of the columns. That means the number of ones in each column is equal to 3 or greater than 3. And the row contains a small fixed number, that is WR, weight of the row. WR is also is greater than or equal to WR is the number of ones in each of the row is greater than or equal to WC. Low density implies that WC is less than m, where m is called as a number of parity check equations. WC is called as weight of the each column. That means number of ones in each column. WC is less than m. And also WR less than n means WR means weight of the row. The number of ones in the row less than n. N is called as the number of length of the code word. Length of the encoded code word or block length. Is satisfied. Number of ones in each parity matrix H is equal to Total number of ones, each parity matrix H is equal to WC into N is equal to WR into M. WC is called as a weight of the column. WR is called as weight of the row, each row. WC into N is called as block length. M is called as the number of parity check equations or number of rows of the H matrix. Here M is greater than or equal to M is greater than or equal to N minus K. The number of information bits K is equal to N minus called as a number of message bits. Ldpc like block codes. Ldpc is a linear block code. It is represented by N comma K. N comma K. That is code rate is R is equal to K by N. R is equal to K by N. That is greater than or equal to 1 minus omega C by. We know that omega C into N, omega R into M. K by N. Here K by N. N is equal to, we know that K is equal to N minus N. Some important derivation is there. That derivation is important to prove that N minus K, here M is WC into N is equal to WR into M. Here, so WR into M is equal to WC into M. M is called here, M is equal to N minus K. N minus K, WR is equal to N into WC. N into WC. From this N minus K is equal to N into WC by WR. We know that code rate R is equal to K by N. From that we have to calculate N minus N into WC by WR is equal to K. Here N into WR minus WC by WR into WR is equal to K. Substitute K value in that expression. K is equal to N into WR minus WC by WR by N. N cancel. Therefore, code rate R is equal to 1 minus WC by WR greater than or equal to. That is R is equal to 1 minus WC by WR. One more important thing is WC less than WR. The number of ones in each row is greater than the number of ones in each column. One more condition is the number of ones in each column is greater than or equal to 3. Is greater than or equal to 3. Ldpc codes are linear block codes, which with very large code word length n, hundreds, thousands, usually in thousands, n greater than 1000 and or 10,000. The parity check matrix H for these codes is a large matrix with very few ones in it. That is the large H matrix. The order is 15 cross 20, 20 cross 40, like that. Number of ones in each H is small. Number of ones in H is small, less than 1%. Example 10, 2, 4 Ldpc code. Here 10 is the code word length. That means the number of ones in the code word. The number of bits in the code word, not ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. 2 is the column weight. The number of ones in each column is 2. Here is the 2 each column, like that. That is the weight of the each column, that is 2. Next one is 4, weight of the each row, that is 4. 4 ones in 4 ones are there. Here 2, 2, put like that. Here 4 ones, that is the weight of the each row. 2 ones, weight of the each column. Depending on parity check matrix, LDPC codes are classified as regular and irregular codes. Rows and columns are regular. LDPC code H matrix contains constant number of ones. That means each row contains constant number, means here fixed number of twos are there in each column. Number of ones are there in each row. This is also constant number. That is called as regular. The parity check matrix maintains constant ones in each column and the constant ones in each row. That is called as uh, regular LDPC. Rows and columns of regular LDPC code H matrix contains constant number of ones. Irregular LDPC code is one in which the number of ones in row and columns of H is not constant for all rows and columns. This is the H matrix, 2, 3, 2, 1, like that. Here 4, 3, 2. Different, not uniform, not constant. That is called as a irregular LDPC code. Regular LDPC codes are easier to generate, whereas irregular codes with large code length have better performance. Large code length, n is equal to greater than or equal to 1000. This is the parity checkmate. Generally, H is the dimensions of H is m cross n, where m is called as the number of parity check equations or the number of rows of the H matrix. N is called as block length. From this H matrix, here one column C1 plus C2 plus C3, C4 is not there, C5. Here C1, C2 is not there, C3, C4 is there, plus C6. Next C1, C2, C4 and C7. Here M is equal to 3. N is equal to 1, 2, 3. N is also 3. M is equal to N minus K. M is equal to N minus K. That is equal to 3 is equal to 3 minus K. Like that. Okay. This is the M is equal to 3. Not N is equal to 3. 1, 2, 3, 4, 5, 6, 7. This one is 7. 7 minus K. Therefore, K is equal to 7 minus. The number of information bits are 4. The number of information bits are 4. These are the parity check equations. This is the 3 cross 1, 2, 3, 4, 5, 6, 7. Column weight is here is 1, 2, 3. 3, here 2, here 2, here 2, here 1, here 1, here 1. Row weight here 3, 1, 2, 3, 4, 1, 2, 3, 4. This one is irregular LDPC code, LDPC parity check matrix. Next one, properties of LDPC code. Once again, I will explain. H is sparse. Sparse means very few ones in each row and each column. More number of H matrix contains parity check matrix of that LDPC codes contains more number of zeros than ones. More number of zeros. Okay. H is WR, comma WC LDPC code. That each row is of a fixed weight uh, 4, 4, 4, 4. The number of ones in each row is 4. That is fixed, the constant one. The number of ones in each column, that is a fixed, constant. Okay, that each row is of fixed weight WR. This is WR, fixed weight, and column is of fixed weight WC. That is called as a regular LDPC. If not, that is irregular. Suppose LDPC code is a n comma k block code. H is the dimensions of H is n minus k cross n. Here m is equal to n minus k to n minus m. N minus k into the number of ones in each matrix, or n minus k into WR is equal to n into WC. Here n minus k is m into WR is equal to n into WC, where m is called as the number of parity check equations, WR is the weight of the each row, n is the block length, WC is called as weight of the column. Code rate is equal to k by n, already there is equal to 1 minus WC by WR.